complementary and supplementary angles. Now we're getting into kind of how do the angles relate to one another. We're also getting into some of the very useful tools which help us to answer one of our big ideas. If you look up at the front board, one of the essential questions we need to answer here is, how can missing angle measures be found in shapes? Well, complementary angles, supplementary angles, and vertical angles all help us to do that. Talk about what? Complementary, first of all, are angles that add up to 90 degrees. Now, you know this, you've done this before, but imagine, if you would, that I have two perpendicular lines, like so. And I know they're perpendicular. I've got this little symbol here that tells me that it's 90 degrees. Well, let's say also that I have a line or a ray in between them. Well, then I know that this angle and this angle are complementary. They go together to make 90 degrees. They go together. They add. So by looking at this, I know that together they equal 90 degrees. Well, let's say that I know this is 60, but I don't know this. That's x. Well, it's very easy to find x now, isn't it? Now I can just do 60 plus x equals 90 and solve for x. X equals 30. So that's one way that I can figure out what my angle measures are. Supplementary add to 180 degrees. So same thing here. Remember we said earlier, this very important point right here. If I have angles that add up to 180 degrees, if they add up to 100, or they're going to form a straight line. Okay, so down here I got GKF, and I could also say GKJ, right? There's an obtuse angle. It doesn't have to be three angles that go together. I could say, well, here's an obtuse angle, GKJ, that adds up with FKG to make this 180 degree angle, this straight line. So it's whatever gets me there. I could go the other way as well. Erase this. Another supplementary angle pair here would be if I go FKH, so there's the obtuse angle that goes with the acute angle HKJ. They both get me down. They both take me from here, from this endpoint F, all the way to J. Or, in the other example, we went from J to G, and then from G the rest of the way home. So we went JKG, that angle got us to here, and JKF, that got us the rest of the way around this hemisphere, this semicircle. So there's supplementary angles. Now imagine if I knew that GKF was 20 degrees. Well, then I can very easily figure out GKJ. GKF is 20. I don't know GKJ, well that's X, but I do know they equal 180 degrees because they form a straight line. So very easily then, X is 160 degrees, that's GKJ. So just an example of how you can use those. Vertical angles are even easier. Okay? Vertical angles, if I know one, I know the other. Anytime I have two intersecting lines, anytime the angles that are across from each other are equal to each other. That's a property called vertical angle tensor. There's a, get rid of this. This one and this one. Those are vertical. On the sides, this one and this one. Those are vertical. So if I know this is 105 degrees, then I know this is 105 degrees. And I also know, this is the key part, I also know because purple and green form a straight line, I know this, the green and the purple make supplementary angles, so I can also figure out this one by doing 180 minus 105 and getting 75 degrees. So you see how we can use vertical to figure out the ones across from each other. We can use supplementary then to figure out the side-by-side angles that make 180 degrees. Okay, go ahead and do the last example, and then take the third and final check-it.